it's written you cannot start screen share while the other participant is sharing. So you unmute. Sorry.
Yeah, it's possible. You can share now.
Oh, now I guess I can. So let me try. Okay. Can you see my screen?
Yeah.
Perfect. Yeah. So we had a great talks about businesses on the Earth. Now let's take a look into the space. So let's talk about a bit about space exploration, and especially we will focus on Moon. So why are we talking about space anyway? Isn't it something that will happen, I don't know, in 50 years? And this is a thought that a lot of people has, and apparently it is wrong. Because if you look into the numbers, you will see that the space market actually grows. And by 2030, the approximate size of the market will be about 1 trillion. But also the market changes. If we would look, let's say, 70 years back, 60 years back, then all the space exploration, space missions were funded by government. Now the situation changes. In fact, we are currently are already in the new space economy when the amount of private funding grows, and it will be annual private funding will be above 20 billion by 2030, and these numbers are growing in each dimension. So the number of satellites grows, the number of launches grows, and the price of the one parameter that decreases, luckily, this is the price of the launch of the payload per kilo. So when we were using space shuttle, it was about $65,000 per kilo to launch to low Earth orbit. Now, with the Starship, as soon as it will be finally ready, it will be less than $100 per kilo, which is super cheap. So the space market, the space economy is growing, and yeah, definitely, this is one of the reasons why we are talking. Another reason you can see here on the screen, of course, this is not the true photo, but this is the visual representation of the asteroid called Psyche 16. It will be flying somewhere pretty close to the Earth by 2029. And the funny thing that lots of companies, lots of terrestrial companies are looking towards its approach, because its price is $10 quintillion. Mostly it's due to the amount of resources like gold, nickel, platinum that it contains. So already, like several years ago, there are missions that envision landing on the asteroids, grasping some small portion of the asteroid and returning back to Earth. And as you can imagine, a small portion of $10 quintillion is pretty decent sum of money. So all the mining companies are interested in this, and you know it's also very interesting how it will change the Earth economy, because if with the advancement of technology we will suddenly receive tons of gold, nickel, platinum, or other resources here on Earth, then the situation will change, because naturally the prices will go down. So yeah, it would be very very interesting to see how what will happen. And this is another view on the space market. So there are two dimensions here. As you can see, there are projects with a short time span implementation and with long time span implementation. And so The first one are obviously the satellites that fly over the Earth. It is connected with Earth observation, geo information, satellite servicing, etc. And when we are talking about long time span implementation, we are talking about human on Mars, space habitants, etc. And don't smile when we are talking about space habitants. Maybe you have heard that the Artemis mission, which is already launched for a couple of years, it should bring humans to moon again, and it should be the some village there, let's say, and humans should be constantly there first for, let's say, a week, and then this time might grow. So they will change. The crew on the moon will change, same as it is on the International Space Station at the moment. And there are also two other dimensions. So first, it's B2C and B2B. When we are talking about B2C, it's like internet, IoT, media stuff that we are all using. And of course, we want our internet speed to be higher. And we hope that with the advancement of satellite constellations, that would be the case. And when we're talking about B2B, again, we are talking about some manufacturing even, because some dangerous and manufacturing that threatens the Earth's ecosystem can be moved to space, and this will make our planet a better place to live. Yeah, so lots of happenings there, and let's talk a bit about the place of SoftServe as we see it in that domain, in that market. Before saying a few words about the group itself, I like to mention our centers of excellence. So we have a few of them, like critical services, solution experience, design, and intelligent enterprise. Particularly, the robotics group is a part of intelligent enterprise together with big data, data science, IoT, extended reality, and some other groups. So this particular composition of centers of excellences allows SoftServe to approach the technologies that are not commodity on the market, and ensure that we always have the necessary expertise and experts that can address the emerging needs of the particular industry. And then doing a deeper dive into the robotics core expertise. So we are able actually to provide end-to-end solutions to our clients. So we have a mechatronics team who are able to design the hardware. We have milling machine, drilling machine, welding machine, with the help of which we can design the production-ready copy of the product. And following the simulation first approach, we are first working on the robotic solution in simulators like Capella Sim, Gazebo, NVIDIA Isaac Sim, and others. And there we are first of all, we are working on the autonomous robots, and we are also working with digital twin, navigation, cloud robotics, etc., human-robot collaboration of various kind. And in order to have the ability to provide the advanced solution, and with optimal, let's say, performance and energy consumption, etc. We also have a team as a part of robotics group who is dealing with cost simulation, optimization, physics-based system, real-time control, physically informed neural networks, and others. And Mariusz will be talking more about that later today. And of course, we are having we are also working on the robotics perception. So we are doing data acquisition from various sensors, sensor fusion, and synthetic data generation is a hot topic. So we are definitely there. And yeah, so reinforcement learning and others. So we are basically working with mobile platforms, drones, arms, where we are working with select robot conveyors and conveyor systems. So this is a few words about the group in short, and let's move on to the next slide. Here it is highlighted the space expertise, because it's easy to say that you are active in space, but it's really the market that it's difficult to penetrate because of the risks. Basically, when you're talking about the terrestrial application, and when you want to try it, you can go outside your lab, and a lot of projects can be tried there, or you can, let's say, move to the facility where this robot or some device will operate, and you can do these tests there to the extent that is required. But when we are talking about a robot that should land on the asteroid or perform some actions on the moon, then the testing is quite not so easy task. So when we're talking about the space expertise, so we have space expertise in mechatronics and simulation. We have experts with like the combined expertise is more than 20 years of doing the space project. One of the persons from our team was leading the Spirit and Opportunity Mars missions. Maybe you heard about them. They were working for 7 and 14 years on the Mars instead of 3 months. That was the initial mission lifespan. And yeah, so this what helps us to approach that the projects and like be sure that we are able to deliver them. When we are talking about the space in general, for us, we divide it into 4 chunks. So first, it's satellite-based Earth observation, then it's communication and connectivity, then it's sustainable space, and this is really an increasing problem because the amount of space debris is growing. First and most obvious are old satellites that are no longer functioning, but also other objects. And it is provisioned that if nothing will change, in 15 years, it will be very difficult to find a window to perform a launch, because there are millions of particles from the size from 10 millimeters to a couple of centimeters, moving with the speed of 36,000 kilometers per hour in the orbit. And when they hit the, let's say, a spacecraft, it can be seriously damaged. So this sustainable space is like a task that is being addressed by different governments and different companies. So yeah, due to human activity, we are trying to remove debris not only on Earth, but we managed to put it in space also. And the last chunk is lunar and planetary robotics exploration. So we are talking about Moon, Mars. Maybe you also heard that there are scientific approaches that and scientific reasoning how we can terraform even Venus to make it atmosphere bearable for a human being to stay there for some time. Yeah, so that's it. And then let's talk about some success stories. And the first one is the project that we did in simulation so far. So we have the IP, and we are currently working on the with partners, of course, towards having this solution flying on the moon on the real drone. So the goal of the project was to create a 3D map of the surface, craters, and caves that are there on the moon in order to search for ice. And ice is really very precious deposit for the moon. If you recall, I mentioned that the price of the launch to low Earth orbit will be about $100, and currently it's about from about $2,000–3,000 per kilo. Now this the launch to the moon is something else. It's from $1 million to $1.5 million of anything. Is it air, water, whatever? And imagine that you find an ice on the moon. You can, from this, you can create water, you can create oxygen to breathe, and moreover, you can create fuel. Let's say, for instance, Jeff Bezos' company, Blue Origin, is already designed and have working engines that are ready to work with the fuel that will be obtained from the ice. So it's like hydrogen, oxygen, liquid hydrogen, liquid oxygen. So let's start the video. I doubt that you see that you hear the sound. So let me comment a bit. Maybe I can jump over. I can share the video with you, but due to save some time, maybe I will jump to the part. Yeah, so it was here. Right. So this is the simulation that we created in Isaac Sim, which means that we not only recreated the like visual environment, but also all the physics is there. I will also took into account the moon's gravity. And the drone is being equipped with two cameras and an IMU, and is able to create the point cloud map, as you can see here, and further recreate the 3D environment where the ice can be found. Of course, there are no propellers on this drone because there is no atmosphere on the moon. But in turn, it is equipped with the propellant engines, and it basically hovers on top of the surface, let's say with 10 meters above this surface, in order to be able to capture the set of images and then further map it with the point cloud map that has been created. Right. So yeah, let's move on to the next slide. This is another project that we worked, and it aimed to collect the regolith to perform the chemical reaction to extract oxygen. Regolith that I'm mentioning is the soil of the moon. And unlike the Earth soil, it is very enriched with the oxygen and iron. So these are the main resources that can be obtained from it. And like, though there were some decent amount of humans on the moon in the previous century, but we still don't have enough regoliths on Earth to perform the necessary experiments. And in laboratories, they use simulant, regolith simulant. This is some kind of a copy, but it's always better to be able to do the tests in the real environment. So the goal of this project was to create a payload that would fly to the moon. It should be able to collect some portion of regolith, and you can see this robotics arm here. And so it's a yellow with a scoop in beneath, and it should grasp the regolith from the surface and place it into this violet box. And there, the chemical reaction conducted by our partners should happen. And yeah, it should prove that the technology that is created is valid. Right. So the next project. So we are. You might have heard that currently SoftServe is collaborating with. Excuse me.
Sorry, it's technical issues. It's okay. Sorry.
Okay, cool. Right. So we are collaborating with NASA, and we are working on the project that aims to build the launch and landing pad on the moon. So there will be a fleet of robots that are depicted here that would collect the regolith, then using the technology created by our partners, it would assemble the bricks from this regolith, and then we will have like this surface for landing and launching. But why is it needed? As you know, that there is no atmosphere, but when the on the moon, but when the spacecraft lands, the gases emitted from the engine moves up the particles of regolith, and due to their highly electromagnetic nature, they are sticking to all the sensors, and basically aircrafts are landing blind because no sensors can work in this environment, so last few meters. And this is actually the cause of the accidents that happen when we are landing on the moon. Like maybe you have heard that the Intuitive Machines was the first commercial companies that successfully landed on the moon, and they had issues during landing. This is why it was not fully successful. And but since their spacecraft worked and the payloads that they had were functioning successful, it was decided that the mission is a success. But still there were some issues, and with the help of this launch and landing pad, we definitely would remove these issues, because there will be no regolith there. As there is no wind on the moon, we can be sure that there will be no dust, and at least this portion of the risk will be handled. Right. So the next project that we are working on is moon scooping. As you understand, in order to be able to build something from the on the moon, we cannot take concrete there, because as I told, 1 kilo of anything costs from 1 million to 1.5 million. So we have to manufacture all the building materials there, and this is why we have to dig them somehow. So the robots with the scoop is a great choice, but additionally to that, we can also search for ice, because some deposits of ice are under the surface of the moon, and being able to find them again, it's a great success for humanity. So what we did, we created a robot. It was created by our mechatronic team, so it is like ready to be enhanced, and it's like a mock-up for a robot that would fly to the moon. We designed all and programmed the robotics arm. Here you can see the object, which is a vibratory unit. So we provisioned that in some places it might be difficult to dig the regolith, and this is why this vibratory unit does the lateral motion and is acting actually as a knife to help the scoop to penetrate the regolith. And the ultimate goal is to reduce the energy consumption, of course. And also you can talking about energy consumption, to the left, you can see the plots that are being displayed. So they are calculating the force that are acting on the scoop, and with that we are calculating the momentarily energy consumption and combined energy consumption of this mission. Additionally, the perception part of the robot searches for ice in the real time. Okay, let me move on. Right. So here I don't want to stop too long, but let me explain what is the architecture just in a few words. So we have a simulation here. So this USD stage is the simulation with the robot and environment and the physics. And we have the we have two basically FMU nodes, and this is important here because in order to calculate the forces that are acting from the scoop to the regolith, we are using thermomechanics. And so we basically use differential equations that are calculated in Modelica in this case. And using cost simulation and cost simulation master, we forward the signals from the Modelica to Isaac Sim and backwards. So sensor readings from Isaac Sim to Modelica in order to calculate the forces that are acting there. And yeah, so of course some user interface is here, image processing, and an ARM controller. So the simulation is in the center and using ROS, which robot operating system, in case you didn't heard. So we control the robots, and using the simulation approach, we augment the general purpose robotics engine with high fidelity physics. But let me stop talking about cost simulation, as I don't want to spoil the Mariusz session that will follow. So just to, like, since this is the scientific conference, I decided to add a few formulas here. So this is basically how the forces that are acting on the scoop are calculated. This is based on the paper. So there are different types of forces that are acting on the scoop itself and on this the first part of the scoop, the blade actually. And yeah, we used these formulas and implemented them in Modelica in order to calculate all the forces. The paper actually did this for Mars, but we adjusted this approach, taking into account the Moon and also the design of the scoop that we used in our case. Well, that's actually it from my side. Since we have like a few minutes for questions.
Thank you so much, colleagues. Questions? So our dreams became reality, and we have opportunity to be creator of this dreams. Yeah. So please.
May I?
Yeah, Maxim. Yeah, please.
Lubomir, nice to meet you. It was very interesting report. Maxim Savelyev, Institute for